So today I didn't prepare anything beforehand again because I was busy finishing the translation of two songs that I started earlier this week, and I finished them. I'm quite satisfied with the translations, and I will record these two songs later this week. Later this week, I mean during the next week. And right now I'll try to think about something more scientific than just describing the impressions about different movies that I watch from time to time. Let's talk a little about mathematics, and I like mathematics in the sense of basic stuff that is usually given in the elementary school and in the middle school, like all the stuff, drawing graphics of the basic functions in the plane. The interesting thing is that somewhere in the 10th and 11th grade, the material that was given in mathematics was quite complex, and through the 5 years of university, the differential equations and calculus and other stuff, it was really difficult because it was the instruments of the university level to help physicists to solve the physical problems, physics problems, the way physicists usually do, like what? The average physicist, maybe in the beginning of the 20th century, I don't remember, but in particular maybe 1904, 1920, like someone Planck, the guy who discovered quantum physics. The interesting fact behind his biography, that when he came to the university, his teacher on physics said to him that he had nothing to work on because every known field of physics were developed quite well, and there was no areas where this young Planck could apply his knowledge, his abilities in physics. And later, Planck was one of the scientists who created the quantum physics, and even one constant one numeric number value was named in the because of in the honor of Planck, something like Planck constant, the constant of Planck. Well, I recall this from physics, from the university, and even from the encyclopedias like Avanta that I got and I read them when my major was physics. And in Avanta in particular, the authors gave the historical overview of the development of physics since the ancient times, like ancient Egypt, ancient Greece and ancient Rome, then through the Middle Ages, through the new time with Newton, Galileo and Copernicus, and then to the modern times with Einstein and the theory of relativity, and Planck with Planck and Niels Bohr with the quantum physics. And the authors gave short summaries, short paragraphs on the biographies of these great physicists, Planck, Bohr. Yeah. And it was quite interesting to learn because it expanded my understanding of physics far beyond the formulas and the tasks that were given and exercises that were given at school and in the university. But unfortunately, I didn't follow the path of the physicist. This knowledge of biographies of great physicists and some interesting facts from their biographies, all this stuff remains just in my memory and in these books, because even in the real life I can't really find the way to to say about it, to tell somebody about it, even with the history of computer science and programming. There is no many points where I can say something from the history of people who created the computer science, like Nicholas Wirth and Van Neumann and other guy. And anyway, it's more like I read their biographies and then I forget about them because I never use them. I never refresh my knowledge by listening to some educational programs on the history of programming, because usually you don't need to know, or maybe you don't need to remember the facts from their biographies to be a programmer or a physicist, or even you don't need to know the biography biographies of Louis Pasteur and Avicenna to be a good doctor. Yeah, usually you just need lots of practice, some common sense, logic, and you need to make lots of efforts to put all this stuff together. Yeah, but because this thing exists about the biographies of different physicists, it could be cool to have the similar stuff in English, like the children's encyclopedias in English, just to know how these notions and different terms from the physics, how they sound in English, because sometimes it's kind of natural to put, I don't know, some quite common knowledge from the theory of relativity, like this famous formula created by Einstein. E is E equals m multiplied by c squared. Yeah, energy equals mass multiplied by squared speed of light. Squared speed of light. So the thing is that well, maybe this is the only application from the relativity theory that can be used in the like common conversation, but some other stuff like Schrödinger cat or just the idea of the speed of light, they can be used, and to use them in general I need to know how to tell them in English. And other stuff like in the optics, this angle of changing the angle when the light falls on the surface and changes its trajectory by moving with the different angle, like according to the surface, then the angle with which this light fell on the surface. And this particular phenomenon has its concise physics term, and the most interesting thing that we can observe this stuff. For example, when you put the spoon in the water and then in the water in some clear in some clear glass, like the opposite to opaque, and when you look at the spoon from the side, you see that the straight line of the handle of the spoon kind of broke somewhere where the spoon touches the surface of the water, but the spoon remained intact and straight, and only because of this effect with the water and with the light we have this phenomenon. So in general, it could be cool to know most of these popular terms that I can use in my everyday speech without additional knowledge, like reading the book on physics to get the formula, or to refresh some memory in my head. Or for example, this interesting some interesting laws from mechanics, the three laws of Newton, but really I don't remember. For example, the idea behind the second law, which was about the impulse momentum. Yeah, I think this law introduces momentum, but I don't remember what it was about. And the famous third law about that action is equal to its counteraction. The famous example for this law is about imagine let's say the lake, and there is some peg, some tree on the shore. The rope is tied to this tree, and someone stands in the boat in the lake, and he holds the rope at the end of the rope, and the beginning of the rope is tied to the tree. Then this guy starts to pull this rope towards himself, kind of. He pulls, and of course he makes some kind of steps over this rope with his hands. He moves his hands over this rope towards the tree to make the rope shorter, but he pulls the rope at the same time, so that because rope can't stretch, he kind of pulls the boat towards the tree, towards the shore. So this is the first situation, and in the second situation, again, the guy in the boat holding the end of the rope, but the beginning of the rope is in the hands of the other guy, who stands on the shore instead of the tree, and he pulls the rope with the same power as the guy in the boat. And the question for this task in some popular book on physics was who will bring the boat to the shore first. And kind of the common sense logic says that the situation where two guys pull the rope will reach the shore faster because there are two guys pulling the rope. But according to the third law of Newton, where the action is equal to its counteraction. In the first case, kind of the guy will be pulling the rope with some force, but the tree, according to this law of counteraction, will be pulling the rope with the same power, and basically there is no difference whether the rope is tied to the tree or whether the other guy on the shore pulling this rope. So in other things equal, other conditions equal, both boats will reach the shore at the same time. Well, actually, I never understood this idea behind the third law of Newton, but I always thought that if the guy with the tree kind of got, let's say, 20 centimeters of the rope each pull, and two guys with the rope, one on the beach and the other in the boat, they both pulled the rope with the same power or with the same force. So I always thought that one guy will pull 20 centimeters of the rope, and the other guy will pull 20 centimeters of the rope for each pull. So obviously, because they shorten the rope by 40 centimeters each pull, then they cover this distance 2 times faster than the first guy who shortens the rope only 2 centimeters, 20 centimeters each pull. So this is the example when there is no special formulas or conditions for the appliance, for the usage of the third law of physics in some everyday situation, in some common sense, even though this task is kind of artificial, but it's easy to imagine. The solution just goes with your imagination. And the simplest first law of Newton about inertia, the inertia, it says that if the object stays still, then this object will always stay still until some external force won't or just don't give him some impulse, and vice versa. If in some vacuum in cosmos the object moves with some, I don't know about the acceleration, but with some constant speed, then if nothing will affect the object, if nothing applies to the object any forces, then this object will continue to move with its constant speed forever. I don't know about the acceleration. Well, I think that's where the second law of Newton comes into play. into the play. Like if you need to accelerate the object, you need to apply some force to this object, and okay, I remember this. F equals m multiplied by a, which means force applied to the object of mass m equals this mass multiplied equals to this mass m multiplied by the acceleration a. So if you need to if you need to give the object some acceleration of a, like 5 meters per second, and the object have the mass of 10 kilograms, then you can calculate what force you need to apply to this object. Like 5 multiplied by 10, you need to apply 50 newtons to this object to make constantly to make this object move with acceleration of 5 meters per second. Okay. Okay, and the same goes from the other side. Like we have force of 60 newtons, and we have the object of 12 kilograms. What acceleration can we give to the object if we apply this force all the time to the object? And the answer is we can move the object with the acceleration of 60 divided by 12 equals 60 divided by 12 equals 5. So we will give the object the acceleration of 5 meters per second. Well, this is the very basic equation, but you know, and I'm not sure that the verb give the acceleration, apply. If we apply some force, then we will give some acceleration to the object. It's not very correctly, because in physics, in Russian, there was some particular verb that was used in the physics books, in the physics exercise books. So it could be quite interesting to learn this simplest physics terms like force, because in the beginning I talked about power, but power is more from electronics. I think that the value of the current multiplied by the value of I can say tension, the sign for this term is U, and this is the difference between two potentials. In 2 points of the electrical circuit. Yeah. So let's say Ohm's law. It says that our resistance, the resistance of some particular, again, all these words that I would like to be able to pronounce correctly in English, but I need to know them, like yeah. So the resistance of the particular part of the circuit is equal is calculated like this difference of potentials divided by the value of the current which flows through this circuit. Very basic physical law, and you can apply it in like in everyday knowledge, because everyone switches on the light, and it means that everyone uses the electricity, the notion of the current, this difference of potentials. So I'd like to learn at least these basic terms, because I don't need to know more than that to speak on my everyday basis. And the same is true for mathematics. I don't need, for example, the terms for these equations when we have x to power 3 plus x to power 2 to x to plus just x plus 1, and in mathematics in Russian it is called like one particular something entity, but I don't know the right name in English, and really I don't need this stuff because I won't use it anyway. But some basic notions from geometry, like plane with the axis x axis and y-axis, and the graphics like parabola, maybe hyperbola, straight line. Well, all this stuff is quite and the forms like ellipse, triangle, oval, they all quite common in the everyday life. When you look around yourself, you can describe the room like parallelepiped, which has 3 pairs of planes which are parallel to each other but perpendicular to other planes, and the room has its volume, its square, if you talk about the square of the floor, perimeter. And just to know these basic terms is the satisfying level for me. But first I need to get these terms, because in the ordinary, in the general books about textbooks about everyday life with different topics like social issues, I don't know, pollution and other stuff. They don't use the specific terms from physics, chemistry, mathematics, banking, accounting, other stuff. And really, I don't need this stuff in general, but sometimes I can read, for example, some stuff from economics in popular newspapers, or listen to the stuff or hear the stuff in the news, like demand of some product is higher than the supply for this product, or the prices for the product maybe some percent something, complex percent, I don't know, all the stuff that is quite popular through everyday life. Well, I'd like to know this and have the possibility to put this in my conversation from time to time. Sometimes, why not? A current exchange of dollar, or something from history. I learned some time ago the word pharaoh. It's popular. It's like I take the topic of ancient Egypt, and then I just recall and write down all the terms that I know from this topic, from my school, from the textbooks that I read, and from everything that I heard about this stuff during all these years till now. And then I just take all these terms, translate them into English, and then I can use them just for fun, without describing the plot of the movie. I can say some stuff, because this stuff is quite common. So in the popular culture, we can meet this stuff a lot. For example, in some of the Agatha Christie's story about Hercules Poirot, he investigated some case when guys who opened the grave, for example, of some pharaoh during this digging stuff in nowadays Egypt, they started to die one by one, and the newspapers decided that was the curse of the pharaoh. So the next guy who should die with this who should die according to this curse was it doesn't matter, some young man, and he asked Poirot to, well, I recall it right now that I read this story in Russian maybe more than 20, maybe 25 about 20 years ago. Yeah, 20 years ago. And then maybe 5 years ago I watched this particular episode of Agatha Christie's Poirot with David Suchet, and now I recall some moments when Gastings went somewhere, but he should guard this young man all the time, and then in the end Poirot drank some stuff, and he was kind of he got this illness, or maybe he was poisoned, but in the end he survived because he like played all this stuff when he like found out the culprit, the murderer. Anyway, in this quite modern story of the beginning of 20th century, they used lots of terms from ancient Egypt history, like pharaoh, pyramids, curses, and other stuff. So to understand this without big troubles, I need to know these basic terms, at least these basic terms, because my basic knowledge in ancient Egypt that was taught for me in Russian is quite alright to understand the idea behind this. I just need to know how to pronounce correctly all these words in the case I want to retell the story to someone. Anyway, yeah, and well, it's not the case with the ancient Egypt, but for ancient Greece and ancient Rome, I can say there is an interest of the mythology, like Zeus, Hera, Hercules, or Heracles, Apollo, and other guys, because they are quite popular and they appear in in Bible. Abraham, maybe David and Goliath, I don't know. All this stuff is quite popular and it appears in popular culture here and there, sometimes in the advertisement videos, sometimes in some stories, in some movies, and so on. So it could be nice to know this basic stuff from quite specific vocabulary, just to know it and to use it during my life. Like say something that Zeus uses. Well, Zeus was the main god in ancient Greece. He, with other gods, lived on the top of the Mount Olympus. He managed the sky. He used the lightnings as his weapons. Maybe when he was angry, then the thunderstorms appeared in the sky. When he was happy, the sky was clean. So the same goes with Hades, Poseidon, and the small stuff that I recall from my knowledge of ancient Greece from Russian, like first it was chaos, then Kronos appeared, and Kronos had many, maybe 12. Yeah, Kronos had lots of children, but someone predicted to him that he will be overpowered by his children, the way he overpowered his parents. Then there was this fight, the old gods, the new gods, titans, and Zeus with his brothers and sisters defeated his father Kronos, and he became the god of earth, the god of the sky. Then Hades took the control over the underworld, and Poseidon controlled the seas and oceans. And other stuff with Apollo, Aphrodite, Artemida, Hercules, not very much, but simple description of the specialization of particular god, and maybe some interesting fact about this god that corresponds to something in the real world, like Demeter or someone. Hades took Demeter or her daughter, and when she lived with Hades in the underworld, her mother was upset, and there was winter on Earth. And then when her daughter came to her to stay with her for some time, the summer came to the world. So these simple, small knowledges, facts, but they need to know the particular information about these gods and to know their names, to pronounce them correctly. So I think one of my purposes to improve my active vocabulary is to get this specific knowledge from ancient Greece mythology, mathematics, physics, something about chemistry, like base and acids. I never use this in my life. I can't find anything of this stuff, but some substances from to know some substances from the chemistry, it could be quite useful, because sometimes I want to say something and I don't know how to pronounce this stuff, or how this stuff even translated into English. And some special, as I said, special areas like dentist, doctor, feel the filling or put the filling in the tooth. Something about the bank. This will be quite useful, because we use this basic knowledge, like the police started a file on some particular person, because file is like a row in, like they walked in a file, which means in a row, in a straight line, but file is usually an object from computer science, and the same word file goes to the police business. So it would be quite useful just to be able to say this stuff, because it's kind of difficult to say anything. Yeah, and some proper names, Einstein, Napoleon, maybe Hitler, Stalin, because all these proper names, they create the foundation, the scaffolding of our knowledge, and it's kind of difficult to express anything without going to proper names or special words or names of the countries, some historical or modern personalities like Lionel Messi and so on. So yeah, I'll try to add these words to my vocabulary. Now, I think that I talked about 40 minutes, so that's all for today.